I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility, with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Anshuman Saxena, Vice President and General Manager ADAS and Robotics, Qualcomm. On today's episode, we'll discuss the physical AI ecosystem. We hope you enjoy this episode. Asham, welcome to the podcast.
Hey, Grayson. Good to be here. Good morning and good afternoon, good evening to whoever is listening at different times. But really excited to be here.
It's great to have you here, sir, because Qualcomm's enabling the future to be built. I mean, what you're unlocking with Snapdragon is frankly awesome. What was the inspiration behind the Snapdragon digital chassis?
Yeah, no, that's a great question. So basically, we started this journey on the Snapdragon digital chassis probably now over a decade when we started bringing in a lot more computing into the car to bring in experiences, starting with the cockpit and infotainment at that point of time. And as of today, we are bringing in the complete digital chassis, which basically means how do you interact with the car? How does the vehicle provide you a lot more information from the ecosystem, from the cloud and everything, and ensuring safety and comfort from a driving experience all tied together with a much, much better cost and the scalable roadmap that Qualcomm provides on the Snapdragon digital chassis. So super excited about that.
I remember years ago when you were in I think it was Central Hall at CES, and you had this whole display about the cockpit, and I was the leader. You're like, get out of here. And I kept playing with it because what you were building was this really great interactive experience in the cockpit. How did Qualcomm go from building this great interactive cockpit to actually building the entire chassis? What was that journey like?
Yeah, no. So again, think about it this way, right? So the experiences in some way or form used to exist in the car, but they were so fragmented, so distributed. And we started tying things together. First, it was the audio and the display screens. Try to put it all together. Then you bring in Android, for example. How can Android on a car help? And it starts bringing in so much of the ecosystem onto it. Now, when you bring all these things, there is intelligence that has to be brought in. There are so many sensors that are pulled in all together. This distributed nature of the system, put it into one central controller with a central software ecosystem, started making a difference from what you used to see as split experiences into one big cockpit experience. Now, expand that. You're talking about more and more sensors on the car to do the safe and comfortable driving experience. Can you use them to get a better experience inside the car? For example, when you're driving around and you can pinpoint to a particular monument or a building or something, that what is that building about? You will start getting a lot more information from a sensor which was supposed to do emergency braking. Think about that. That starts becoming a Snapdragon digital chassis. And it's not about how you tie the hardware. It is about the system architecture, the software architecture. Now we call it a AI-defined vehicle, AIDV. That's what is coming together as a Snapdragon digital chassis. And we can play in that because we enable the connected cars, all of the connectivity to the backend. We play in that because we bring in brilliant experiences on the cockpit. We play in that because we basically bring in the safety and the comfort, which is core to our development and what we bring in the Snapdragon Ride umbrella. All tied together is the Snapdragon digital chassis. So that's why we are building what we are.
Is it fair to say that the Snapdragon digital chassis is the intelligence layer for the vehicle? It's the brain that's controlling everything?
Exactly. The intelligence, the connected layer, and also the experience layer. So it's not just intelligence, it's what you deliver as an end experience with all the data that is available with a much faster time to market. That is a super important piece. The time to market, because the auto industry is not the way it was traditionally. Like we start something, 5 years later, you see it in the car. It is changing every quarter, every half year, and basically bringing in newer and newer over-the-air experiences to the users like you and me. And that's what Snapdragon digital chassis is enabling.
And you're also bringing autonomous driving with your system on chip architecture. About 2 weeks ago, you put out a press release where the Wayve driver is going to be integrated into the Snapdragon Ride platform. I said, okay, there's something very interesting going on here. Could you talk about that partnership and how it works and what the consumers can expect, please?
Absolutely. So Snapdragon Ride, which is our umbrella for automated driving, starts scaling from anywhere, which is a regulatory tier. By the way, it takes a lot of effort to deliver a safety critical regulatory checkbox kind of implementation across the globe. It's not delivering in say the North Americas or the Europe. It's everywhere in the globe. So starting from there to delivering what we call as a highway and a urban driver assist, where you can have a hands-off driving from an address-to-address standpoint. Those are the features we are talking about, leading to a level 4 system as part of the Snapdragon Ride system. Now, as when we do this, we have deployments across the globe. As I said, we have announced with BMW our first complete Qualcomm developed autonomous driving stack in the BMW Nuva class in September 2025. And since then, we have been enabling it in multiple other vehicles. At the same time, we have a significantly high deployment of Snapdragon Ride in China, where we partner with multiple other different stacks. And most recently, the one that you asked, Wayve AI driver, we partnered with Wayve to bring in the capability of world foundation models that Wayve brings in onto Snapdragon Ride. So think about it. Now we are talking about really scalable platform, which has been proven for safety, active safety critical requirements across the globe, attaches itself to what Wave brings as a human-like driving implementation that can be deployed in a very optimized way and integrated to Qualcomm's safety stack and delivered to the customer. So best of both worlds can be delivered to the customers in a scalable fashion. And that feature set is available from starting from the lowest, what we call as a L2 tier, all the way to a L4 system, eventually going to the robotaxis.
I was in London last year and met with the team at Wayve and went for a ride around London in the Wayve vehicle. I was impressed of what I firsthand experienced. And then I've always been a fan very publicly of your company. I said, oh, okay, so we got Wayve coming together, Qualcomm. Okay, it's something special here. So when I think about the partnership between Wayve and Qualcomm, will it be your compute in the car that will be powering it? So what will it look like from a compute perspective?
So depend again. The beauty of Snapdragon Ride is it's a scalable compute. Super important for us to think about it that way, because not every vehicle can have really expensive and high-end compute with liquid cooling on every car, right? I mean, there are going to be a lot of internal combustion engine vehicles, etc., that will keep deployed at a very cost-effective nature, right? So what we provide is a scalable compute, which basically means different set of sensors, right? And the sensors could be anywhere from 5 or 7 cameras all the way to 11 or more cameras, multi-radars, in the higher ends, LiDARs as well. And this all contributes to a really comprehensive AI driver implementation. What Qualcomm provides from a compute standpoint, and depending upon the tier of the integration, the compute could be for a level 2 compute, or the compute could be a level 2 plus plus level 3 to a level 4 robotaxi compute. We have the scalability across the board, which ties itself to sensors. And we have the active safety stack, which runs on each of these. So the safety stack is delivered by default. Now comes the Wave driver, which can be kind of distilled to different forms of the sensors and the compute based on what they can deliver. And that's the end-to-end offering from the left to the right to the for the automakers.
When you look at the Qualcomm business, it's a very big business. You have multiple lines of business, but what you're describing to me is growth and how you're going to go from different forms of automation. You're going to scale the whole way through. And when I go through your public filings, I've started to notice from your supplements that you file with the SEC, automotive is getting a lot more attention than it used to be. Is automotive becoming a growth business inside of Qualcomm?
Yeah, no, I think the way to look at it, right? I mean, if you start peeling some layers, it's not something that we started bringing in now, right? I mean, this was towards the end of last decade. We started talking about how we are going to be diversifying our businesses, and in the early part of the decade, when we started making automotive as a critical part of our investor communications, we started bringing automotive in the forefront. And we had made some commitments of to the street for the revenue targets, etc. For kind of reminders, we had planned a 2026 FY26 financial year 2026 to hit a 4 billion revenue target for automotive. We already met that like approximately 4 billion in 2025. So a year ahead of our plans. Now, which basically says we are on a growth trajectory on the automotive business. The automotive TAM is growing. We are in the forefront of bringing in newer architectures to the vehicle. So, for example, like you started off talking about the cockpit, right? It was used to be discrete components. Now it became one big cockpit engine to a Snapdragon digital chassis. The growth vector for Qualcomm is significantly high in automotive. But it's not just an automotive story. It's edge AI story. It's connected ecosystem story. That's where the focus has been. We are going towards physical AI. Physical AI has to be on the edge. You cannot have a backend compute to decide what are the next movements that has to happen. And when you talk about edge AI, all the right relevant problems come in. Like you have to have a great optimized implementation. Latency has to be under control. Power has to be under control. It has to run within the same ecosystem of or within the vehicle. And of course, has to be connected to get all the data and the over-the-air enhancements, etc. That's the central piece of how Qualcomm thinks about it. And cars think about it as a first instantiation of a physical AI deployment. For Qualcomm, it's a diversification thought process. It's AI, edge AI, physical AI in the center of everything. That's what we are talking about as we think about the new Qualcomm as we make progress.
And staying on the physical AI theme, we can't talk about physical AI without robotics. I mean, it's the coolest. And I like robots, and now they're cool. When did Qualcomm begin to look at the robotics market?
Yeah, no, that's again an interesting one. So robotics as such is not new to us. We have been playing in the robotics implementation, but they started more of what I would say as consumer robots. We had been playing in that space, but actually last year we started bringing it to the forefront to the external world. How Qualcomm is thinking about its own robotics business and program. So we started working on bringing in the learnings from automotive, from automated driving. Again, if you look at it, the recipes will be very similar. You have to have a big data flywheel. Data flywheel basically means how do you efficiently collect the data? How do you efficiently enrich and curate the data? Curation is what is the data that is relevant for me? How do you use the data for the training? How do you optimize it for the underlying compute architectures? How do you run these? Now it's very commonly discussed the VLAs, the vision language actions. How do you take the sensor to the action and deploy it? The recipes same or similar. The complexities could be very different. One, the car drives at 130 miles per hour, kilometers per hour, or maybe faster than that. Robots don't drive or walk or run that fast, but they can, of course, but not at those speeds. But they have a different kind of a complexity. You're talking about multiple degrees of freedom, which are in multi dimensions, 3 dimensions kind of a thing, right? You're talking about arm movement. Very different problem statement than putting the car and drive it around, right? Data collection is a very different problem statement. We thought we have all the right assets. Again, this is a classic problem of a distributed architecture where you have to have intelligence in your limbs, for example, intelligence in your like a very tight nervous system kind of an approach. You are not talking about a big brain to solve all problems. And even if you have bigger brains, because there is a lot of sensing coming in, it has to be having the same exact problem statements of optimizations, power, etc., that we talked about, which is the DNA of the company. That's when we started talking about that, we have to step up and go into this physical AI in a robotics form embodiment, because that's really the ultimate future of how physical AI will be interacting with us as humans. Safety becomes critical. We have been doing safety for a very long time, starting with automotive and industrial safety as our IoT, industrial IoT business. Bring it to robotics. The know-how exists. The software exists. We are just trying to bring it into a different embodiment and trying to play at again, a system problem versus just a chip problem. That's, by the way, where we partnered with Neura Robotics. Again, yet another leader in the robotics world, a much tighter partnership where we'll be bringing in the brain and the nervous system, as they describe it, and into the robots based on Qualcomm AI, Qualcomm AI stack, Qualcomm AI flywheel, and deliver it to the world.
There's a lot that goes into humanoids. If you research it, the role that magnets play is pretty incredible. But you're right, dexterity. You have to have the dexterity, but then you also have to have high performance and low power, because you can't say, oh, 20 minutes, it's got to go charge. No, that's not good. It's got to be able to do a shot. How do you balance the high performance and low power?
Yeah, that's why I said that, think about it. There are going to be architectures. This is a system architecture problem. This is, again, as I said, falls in the DNA of Qualcomm, of when you take a complex system and start going top down on exactly what you want to implement, right? For example, if you are holding a cell phone or a water bottle with a plastic bottle versus a glass bottle, grips have to be different. And if the bottle, for example, is slipping, you can make the decision right here. You don't need a big brain for this. You just need a limited amount of sensing. The sensing is more than just the cameras. You're talking about the haptic sensors, the force tactile sensors, the thermal sensors, etc. Good example is, you would imagine that, why would a robot need to worry about a hot metal cup which is filled with, say, a hot coffee, boiling coffee? I mean, it's a robot. It doesn't care about it, but it cares about it because at the end of the day, it has to be given to Grayson. So now you cannot the robot cannot hand over a hot. How do you know what is to be done? What is the next action? This can be done a lot within the limb. Of course, the brain is required, but you can distribute the problem and make ultimate reactions. This limb, the hand, might have to operate at like 1,000 hertz, which is one per millisecond kind of action control, while the brain might work at 100 millisecond, 100 times difference. This is how you distribute the computing versus trying to say, I will run much bigger big brain, which will need, like you said, every 20 minutes it has to go back, charge for another 20 minutes, and then come back. That won't work. In the productivity goes for a toss right there.
No, and the other thing, for physical AI to truly scale, there has to be an ecosystem of suppliers and individuals deploying it. What role do you want Qualcomm to play in this? I'll call it the evolving ecosystem of physical AI.
That's again a great question, and something that we continuously focus on a daily basis. This whole physical AI space, robotic space, is an ecosystem play. It's not one solution that is going to be working. There are so much of innovation. If you look around, today it's a relatively fragmented industry, and fragmented because it needs different expertise from different people, right? I mean, you're talking about motor control. That itself is a complex problem that there are experts across the globe. The companies that are working on the motor control. There are companies who build arms, different kind of arms. They have to have innovation in the dexterity. It's not a solved problem. This is an ecosystem problem. How do you simulate? You're talking about simulating a warehouse versus a retail store. How do you simulate? Oh, should I be dependent on only one kind of a simulation environment? No, there are multiple different players who are building expertise on airport simulation versus a warehouse simulation versus a retail store simulation. Yes, it can be done in one tool, but expertise is there in different pockets. Our goal is, can we be central to all of these robotic solutions and build a general purpose robotic stack that can solve the problem of a AMR, automated mobile robot, which does just moving the things, has to be really cost effective, to a humanoid, which again has to be cost effective, but maybe it is a multi-skill general purpose robot, so it can be a little more extra cost. That's how we think about it and bring the ecosystem for that. We are focusing on bringing all the tooling, the general purpose robotic stack, where our ecosystem partners can kind of complement, add on top of it, and deliver the end product.
What's very clear, physical AI is going to play a big role in society. Qualcomm's going to be there to power it and provide, if you want to call it, parts of the ecosystem, from the AI to the chips to the expertise, because you have really great world-class engineers at the Qualcomm Corporation. And as we look to wrap up this conversation, Anshuman, what would you like our listeners to take away with them today?
Yeah, no. First of all, thanks for giving me this opportunity to talk about all the things that we are doing, that I'm kind of driving over here. It's a really super exciting time for the industry, for Qualcomm, as we bring in AI capabilities from the edge AI requirements on a wearable, right? I mean, we're talking about wearables, glasses, etc. all the way to the complex systems of a robot or a humanoid or a car. Very varied problem statements, but they are super connected to each other. You heard about 6G. It is gonna be designed and defined for sensors on the edges and doing a lot of data movement and intelligence around it. It is defined by the edge AI because that's really the key differentiation for every market segment that exists. And we are in the center and the forefront of all of these different segments, bringing in Qualcomm's capabilities to these different markets. Automated driving, robotics is close to me, and I'm really excited what we can bring as a differentiation to the ecosystem.
Qualcomm is powering the future. The future is an ecosystem that enables physical AI. Today is tomorrow, tomorrow is today, the future is Snapdragon. Anshuman, thank you so much for coming on SAE Tomorrow Today.
Thank you very much. It was really great talking to you, and see you sometime soon.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we discuss how lamppost charging could expand curbside EV access using existing infrastructure.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.